Hi everyone, welcome back to the channel. And today we're going to solve Leetcode Daily Challenge, problem number 2444, count subarrays with fixed bounds. So this is a really hard problem. They have marked it as hard, and it was a little complicated to come up with a solution. But I think the solution which I was able to come will be easier to understand. So the question is, we will be given an array nums and two integers minK and maxK. Okay. And we have to find fixed bound subarrays. And what exactly fixed bound subarray is? It means that the minimum number should be equal to the min k, and maximum number of that subarray should be equal to max k. Okay, we have to find all the subarrays in that, and we have to return the number of fixed bound subarrays. Right. So what I'm going to do is I'm going to use uh, two-point extension of two pointers, and I'll be using a three-pointer approach to solve this problem. Two pointers to basically check where my minimum pointer is, when where is my max pointer, and another pointer to denote the start of that subarray. Okay, so let's move to the solution. I think I'll be able to explain you guys better while writing the code. So let's move towards that. Okay, first I'll start with some initialization. First one being I'll use two Boolean variables called minFound, and we'll initialize it with the false maxFound. So these two variables at any given moment will tell you if we have minFind and maxFound in in the current subarray or not. Okay, if not, we will not add into our count, and if yes, we will do that. Okay, next is I want to have start and start which will basically tells you where exactly our subarray starts right now. Okay, and two more variables to denote the location of min start and max start. Okay, and another variable to show the count subarrays. Right. So I'll be using all these variables. Next comes a simple loop in which I'll be using enumerate. So let's say for I and num in enumerate. Enumerate basically gives you the index and the value at the same time, so it becomes a little easier for you. And I think a bit more it is a bit more optimized as well. Okay, so we have the index and the num. What you have to check is if num is greater than max k, or if num is less than min k. So basically, if the current number is not in the range which we were expecting, then we will mark the min found as false and max found as false. Because this basically broke our subarray, right? The subarray which we were carrying forward. And we will mark start as I plus 1. So basically, we will try to look for a subarray after this particular index. Okay. Next comes if num is min k, like if it is equal to min k, I want to point my min start at current index, and I want to mark min found as true. So basically, we found our minimum value. And if num is equals to max k, then also I want to update the pointers. And what it is? Max found. Oh, okay, this done. Now it's a simple loop, simple condition. If we have both min found and max found in a current subarray, right? Min found and max found. If we have both of these, I want to update my current result. And how will you do that? So basically, this start represents where exactly that subarray started from. Okay. And to get the exact location of it, what you'll have to do is you'll have to take the minimum of min start or max start, like whichever is lower, and you have to subtract out the start because this is where our where your subarray started, right? Then just include plus one in it to balance out the equation. Okay. And at the end, just return your current count, whatever count you get after completing this area, this iteration. So let's check out the test cases. And yeah, so the test cases got accepted. Let's submit for further evaluation now. Awesome. So the solution got accepted, and outside we performed really well. We outperformed 94.86% of the submitted solutions. So, yeah. Thanks again, guys, for watching on the video, and stay tuned for the comments. Don't forget to subscribe to the channel. Thank you.